Alright, so let's talk about polynomials in a quadratic form. Polynomials in a quadratic form are polynomials that aren't quadratic but are practically quadratic. This one is in a quadratic form. Why do I say that? I say that because I look at this power, and that leading power, the degree of the polynomial, is twice that middle power, and then there's a constant at the end. That's how you recognize it. You look for a power that's double the middle power, and then a constant at the end. This one is in a quadratic-like form. I have a power that's double 2, 4 is double 2, constant at the end. This is not a quadratic form because 10 is not double 6, even though there's a constant at the end. This is not a quadratic form because 9 is not double 5 and there's not a constant at the end. But there is a GCF on this one. If I take out a GCF, I get 10x to the 8 minus 6x to the 4 plus 3. Now that this piece is in a quadratic-like form because 8 is double 4 and there's a constant at the end. This one is in a quadratic-like form because 12 is double 6 and there's a constant at the end. Okay, I think we can recognize them now. Once you see it's in a quadratic form, how does that help you? It helps you because you could think about the corresponding quadratic. If this isn't quadratic, it's 12th degree. But if it were quadratic, it would look like 2a squared plus 5a minus 3. I can factor this 12th degree by thinking about factoring this second degree, this quadratic. If I were factoring that quadratic, I would do 2 times minus 3 is negative 6. And I would look for factors of negative 6 to add up to 5. Oh, the last one. Isn't it always the last one as you try? 6 and 1. So I'd use those. I'd rewrite this. I would factor by parts. I would divide it in half by a grouping. I factor a 2a out of the left side. That's my GCF on the left. I factor minus 1 out of the right side. That's my GCF on the right. I get 2a minus 1, a plus 3. And that's not my final answer. I factored it. Yay, I factored it, but that's not my final answer because my answer has a in it and the prompt had x in it. And if I wrote a, the teacher's going to look at me like, what is he talking about? This prompt had x. He's totally lost. I have to switch back to x. And I switch back to x by realizing that a and x to the 6 were the same thing. So what I could do is I can write 2x to the 6 minus 1, x to the 6 plus 3. We'll do another one. But that key there was realizing that a and x to the 6 played the same role. I had 5x to the 6, and then I changed it to 5a, so a must be x to the 6. In this one, this is a quadratic form. 10 is double 5, and there's a constant at the end. So I think about the corresponding quadratic that has a minus 15 constant term, a 2a middle term, and 1, this is 1x to the 10th, so I do 1a squared. This quadratic would factor into a plus 5, a minus 3. It's easy to factor because it's the version of factoring where there's no leading coefficient. A plus 5, a minus 3 is how this quadratic factors. How the original problem factors, I have to switch back to x's. I realized that x to the 5th and a were the same thing, so I'm going to change this to x to the 5th plus 5, x to the 5 minus 3. Another. This one is not in quadratic form, but it's one of these ones where if I factor out the GCF, it is. I could take out x, and I have x to the 4 minus 8x squared plus 7. This middle piece is in a quadratic-like form. X to the 4 plus 8x squared plus 7. That's in a quadratic-like form because 4 is double 2 and then there's a constant. So I think about the corresponding quadratic. This is 1x to the 4th, so I do 1a squared plus 8a plus 7. That makes a plus 7, a plus 1. It looks like x squared and a were the same thing. So I'm going to change this into x squared plus 7, x squared plus 1, which that actually is my final answer either, because I need to remember that was just the orange part over here. So the final factoring is x times x squared plus 7, x squared plus 1. That whole thing is my final answer. Let's see. Oops. This is in a quadratic-like form. 6 is double 3, and there's a constant at the end. I think about the corresponding quadratic. Instead of 1x to the 6th, I do 1a squared. Instead of 5x to the 3rd, I do 5a squared. Not a squared, a. Middle term in a quadratic is just linear. And minus 6 is still going to be there. This is the easier version of factoring. What multiplies to negative 6 adds to 5. That'd be a plus 6 and minus 1. It looks like x to the 3rd is the same thing as a. So I'll change this into x to the 3rd plus 6, x to the 3rd minus 1. And as confident as I am, as much as I'm like, oh, I'm so good at this, I can't get overly confident because I'm actually not done. Because this part factors even more. It's difference of cubes. This is going to make x to the 3rd plus 6, x minus 1, x squared plus x plus 1 by difference of cubes. That would be my final answer. One more. This is in a quadratic-like form. 12 is double 6, and then I have a constant. So I think about my corresponding quadratic. I factor the corresponding quadratic by doing 2 times negative 4, makes negative 8, what multiplies to negative 8 and adds up to negative 7. Not these, not these, not these. And by not these were the first ones, I was wrong with these two. I just was in such a roll, I felt like I kept writing. I factor by grouping, by splitting up the middle term, using my 1 and negative 8, 1 and negative 8 here. I factor by grouping, drawing a little curtain, take an a out of the left side, take minus 4 out of the right side, 2a plus 1. I'm left with a minus 4, 2a plus 1, and looks like x to the 6 and a are the same thing in this one. So I'm going to change this into x to the 6 minus 4, 2x to the 6 plus 1. And does that factor anymore? This, it certainly I mean, isn't difference of cubes or sum of cubes, because 2 doesn't jump out as me as a cube, unless I want to think about the cube root of 2. This 4 isn't a cube, but it is a square, and x to the 6 is the square too. That's the difference of squares. It's a tricky one to spot. But x to the 6 minus 4 is like x cubed squared minus 2 squared. So it's going to be x cubed minus 2, x cubed plus 2 by difference of squares. So this factors to x cubed minus 2, x cubed plus 2, 2x to the 6 plus 1. Oh, that was a little bit tricky. But that is my final answer. Just in case you're interested in seeing the original, let's shrink this down. All right.